Welcome to this tutorial on one more geometry proof type problem. A problem that looks like what we see on the left. Now as we prepare to get into this proof, we want to label the picture before proceeding. That's going to help us identify our given. Now I know some people might say, oh, well the given is easy. It's just that angle 3 is congruent to angle 6. And that is true. But there's other things from the picture that we will want to use as givens. So first of all, I'm going to mark the fact that angles 3 and 6 are congruent. But then I'm also going to label that we want to end up with angles 2 and 8 being supplementary. There are two additional pieces of information we will need to lump in the given in order to solve this problem. Look one at a time at the two vertices in this problem. First, let's pretend I don't see any of the stuff down below. What we would see is that we are involving angles 2 and 3, and what we know is that angle 2 and angle 3 are vertical angles. Now we're going to do the same kind of thing, except we're going to block off the top of the picture and focus our attention on the bottom portion of the picture. It's angles 6 and 8 that are labeled, and angles 6 and 8 form a linear pair. So that will be the second item that we add to the given. Angle 6 and angle 8 form a linear pair. If you're very careful and methodical at setting that up, the rest of the proof really should be a bit of a breeze. So we knew that angles 3 and 6 were congruent. In step 2, I'm going to change that to say that their measures are equal. And how do we know that if the angles are congruent, their measures are equal? Well, that was just the definition of congruent angles. Now to get step 3, I'm just going to go down the line in what I have in the proof. Angles 2 and 3 are vertical angles. Be careful on how you write that. So that's going to mean that angle 2 is congruent to angle 3. And the reason on that is the vertical angles theorem, or VAT. Before I forget, I'm going to convert that into saying that their measures are equal, and again, that is the definition of congruent angles. Step number 5, as we continue our way through the proof. I still haven't used the fact that angles 6 and 8 form a linear pair. What that means, for the purposes of this proof, is that their angles add up to 180 degrees in measure, which is the definition of a linear pair. Step number 6. Look at where we want to end up. Always keep your eye on the prize, so to speak. We want to end up with angles 2 and 8 are supplementary. Look at where we're currently at. Look at what we have in the proof. The next thing that we're going to do is we're going to take the fact that measure of angle 3 equals measure of angle 6, and we're going to substitute angle 3 in place of angle 6. And that was simply substitution. Now step number 7. Keep an eye on where you want to end up. That's always important. If you don't know where you're going to get lost. And what we know from earlier in our proof is the fact that the measure of angle 2 is equal to the measure of angle 3. So we can replace the measure of angle 3 with the measure of angle 2, and then we will have that the measure of angle 2 plus the angle 8 in measure equals 180 degrees. That again was substitution. One more step and then we're done. If the two angles have measures that add up to be 180 degrees, we know that those two angles have to be supplementary. So angle 2 and angle 8 are supplementary. And the reason we get that is the definition of supplementary angles. We're done. So really the key to this proof, the key to succeeding on this proof, is looking at the beginning looking at the picture and coming up with your givens. And again, when we looked in this top portion, we were able to say that 2 and 3 were vertical angles. And when we looked in the lower portion of the picture, the angles involved were 6 and 8, and we saw that they formed a linear pair. Once you do that, the rest of the proof kind of works itself out.